Alright class, so chapter 2 is all about graphs. So we're going to cover graphing lines and square roots and circles and radical functions and things like that. So section 1.1 is all about the distance and the midpoint. This is something I have covered before, but I wanted to reintroduce and work through a more complicated example. So the midpoint of a line segment with endpoints x1 and y1 and x2, y2 is found using the midpoint formula. So let's solve one example first. If I have m equals, let's use a capital M for midpoint, and I want to find the midpoint between 3, -6 and 6, 3. So I'll let my first point be x1, y1, and my second point be x2, y2. In order to find the midpoint, what I do is I add my x-coordinates and divide by 2, comma, right, because this becomes our x-coordinate. And then I add our y-coordinates, divided by 2, and that's going to give me the midpoint. So our midpoint is 9/2, comma, -3/2. So the midpoint between these 2 points, 9/2, -3/2. The next thing I want to talk about is the distance formula. So whereas the midpoint formula finds the midpoint on the coordinate plane between 2 points, the distance formula finds the distance between 2 points. So if I have 2 points, x1, y1, and x2, y2, the distance is given by the following equation, where distance equals the difference in x squared plus the difference in y squared. So let's go ahead and work through an example. I have distance equals the square root. Let's label this x1, y1, and x2, y2. I'm going to take the distance between 3 minus and -6 squared plus the distance between -4 minus 5 squared. That means the distance is the square root of 9 squared plus -9 squared. So I have my square root of 81 plus 81, which is 162, square root of 162. 162 factors to 2 times 81. 81 is 9 times 9. So this is going to simplify to 9 square root of 2. So that's the distance between those 2 points. Typically, you are going to end up with a radical in most cases. I'm briefly introducing the Pythagorean Theorem because what we're going to do is we're going to use the distance formula to solve a geometry problem. That's what I want us to do. So given a right triangle with sides A, B, and C, where C is the longest side, that's our hypotenuse, the following equation holds true. A squared plus B squared equals C squared. And when we're given a triangle, the equation for triangle is 1/2 base times height. And if we know it's a right triangle, we can find its area because the base and the height are just the legs of our triangle. So let's take a look at this geometrical application. So let's consider 3 points. A equals -2, 1. So let's go ahead and plot that. When x is -2, y is 1, there's A. B is 2, 3. So I've got when x is 2, y is 3. There's our point B. And I've got C is 3, 1. So when x is 3, y is 1. So the first thing I want us to do is plot our triangle. Ain't she a beaut? But we can't tell whether or not this is a right triangle. What we're going to do first, though, is find the length of each side of the triangle. So I have to find the length of AC, I have to find the length of BC, and I have to find the length of AB. So why don't we go ahead and work through that. I'm going to first find the distance of AB. That's going to be the square root of -2, right, minus 2, squared, so my difference in x plus my difference in y squared. That gives me the square root of 4 squared plus -2 squared, which is the square root of 16 plus 4, so square root of 20, which simplifies to 2 square root of 5. Next, I can find the distance between B and C. That's going to be the square root of 2 minus 3 squared plus 3 minus 1 squared. That's going to equal the square root of negative 1 squared plus 2 squared. That's the square root of 5. And that can't be simplified any further. Lastly but not least, I need to find the difference between A and C. I can write that AC, I can write that CA, and they'd be the same. So the distance is going to be negative 2 minus 3 squared plus 1 minus 1 squared. That just leaves me with the square root of negative 5 squared, which is the square root of 25, which is just 5. Awesome. So here are the lengths of the three sides of my triangle. The next part of this problem says show the triangle is a right triangle. Well, to show the triangle is a right triangle, I know the lengths of any right triangle will work with the equation a squared plus b squared equals c squared. So I will get a true result that my these 3 points give us a right triangle as long as their distances make this a true statement. So let's go ahead and plug that in. I'm going to have one of my sides was 2 square root of 5 squared. Another side was 5 square root of 5. And then my last length of my triangle, the longest side was 5. And the longest side is always the hypotenuse C. This is going to give me 4 times 5 plus 5, which is 25. I get 25 equals 25, which is a true statement. So this is a right triangle. Now that I know this is a right triangle, I can find the area of the triangle. My base and my height are just going to be my legs that aren't the hypotenuse. So I have 1/2 2 square root of 5, and the square root of 5, that's 1/2 of 2 times 5, which is 1/2 of 10, which is just going to be 5. So our area is 5 square units, because I don't know what the units are, so 5 square units. So there we've used the distance formula paired with a Pythagorean theorem to solve a geometrical application.